Hi YouTube. I'm gonna go off the rails a little bit, and this is off topic than what I normally talk about. But I do have a few videos like this, but I'm gonna go a little bit deeper this time instead of little short bullcrap videos. I've been watching a channel called the Thunderbolts Project, guys. I've studied physics myself for many years, and their ideas are just kind of outlandish. So I kind of have a response and also part of a thesis that I typed up myself. So let's just go ahead and begin. The topic is going to be about gravity. What if gravity and the strong nuclear force are one and the same? What if the force that binds the atoms themselves, the strong nuclear force, causes gravity? This may be a real possibility, as we will briefly investigate. For those who feel that gravity is overrated when it comes to the evolutionary structure of the universe and believe that vast walls of plasma and electromagnetic fields played a key role, I have one thing to talk about. Not all matter is affected by electromagnetism, unless it's a conductor of electricity or can be magnetized. Matter of fact, most of all the observable matter in the universe consists of elements which are not affected by electromagnetism, like hydrogen, helium, oxygen, carbon, etc. And then your rare metals and your heavier platinum groups. Even rarer, this is more, which is even rarer, by the way. Excuse me. This is more carbon, there's more carbon-based matter in the observable universe versus conductive material. But on the other hand, gravity affects everything that has a quantitative measurement of mass, which constitutes just about everything in material form in the universe. Anything that is baryonic matter. Just by simple deductive reasoning, I would have to conclude that the major role goes to the strong nuclear force and gravity. Though electromagnetism helps bind electrons to the nucleus of atoms, a nucleus can be stripped of its electrons under very energetic conditions and still remain intact and still exhibit the same properties of that particular element, only with a positive charge. Once energy levels are reduced to a normal level, like lower temperatures, that particular nucleus will borrow its electrons from its surroundings, thus stabilizing its electromagnetic field and becoming neutral again. All matter does this borrowing and re-emitting of electrons all the time. The frequency of this exchange depends on temperatures and on other forms of electromagnetic energy like charged particles from stars. But another force had to play the part of the formation of the star in the first place, and that is gravity. Without gravity, electromagnetism alone isn't enough to produce an object as powerful as a star. And the structure of the observable universe today. I like to think of this idea as simply as an add-on to the theory of of gravity and relativity only. I don't think of space itself being like a fabric being affected by gravity, only that the object within the space are affected by gravity, thus constituting that light has some quantitative mass, signifying that light doesn't traverse through a warped portion of space. Rather, light itself is warped along its trajectory, thus giving the illusion of arc-shaped galaxies or other distant phenomena. This has been observed by the Hubble Space Telescope, so it has been concluded, and these objects have been, these Einstein rings have been observed. So gravity does affect light. This can also provide another conclusion to why we see objects redshift the deeper we look into space, given the illusion that these objects are moving away from us. Thus, due to the resistance of gravity, light becomes further redshifted the further it traverses the universe. The implications of this idea suggest that the universe may not be expanding after all. Well, this goes against the widely acceptable idea of an open universe. The objects within our galactic neighborhood appear to be moving in all different directions. Andromeda appears to be moving directly towards us. And if the universe was expanding, wouldn't everything appear to be moving away from each other relative to each other? Gravity could be the direct result of the interaction of the strong nuclear force and surrounding matter. And as an analogy, if one could imagine the nucleus of a deuterium atom, the proton and the neutron bound by the strong nuclear force, being represented like magnets bound at opposite poles. Magnets bound at opposite poles would give a residual field surrounding them. This field is analog to gravity. Thus, gravity could be the direct result of the force that binds atoms themselves, the strong nuclear force. This field, so to speak, probably isn't noticeable unless larger amounts of matter were present. In fact, that's a fact. In the form of asteroids, comets, planets, stars, black holes, etc. Only further emphasizing why gravity may not be accounted for on the subatomic level. Because you're seeing it as a strong nuclear force, is what I'm saying. So, personally, from a common sense perspective, while observations have been conducted on matter in cosmological proportions, it seems evident that gravity has played a governing role in the evolutionary structure of the universe. Thus, just as well, the same can be said about the strong nuclear force at subatomic levels, how it has played a crucial role in the structure of matter itself. What are the implications of this idea on the theory of relativity? What if gravity and the strong nuclear force are one and the same? What if the very force that binds the atoms themselves is the very force that causes gravity? Personally, from a common sense perspective, I like to say this a lot. While observations have been conducted on matter in cosmological proportions, like I said before, I think it's quite evident that gravity, again, has played a role in the evolutionary structure of the universe. I want to present this idea with the use of a simple analogy, which I basically already did. Here's a couple notable facts, though. The strength of gravity and the distances of massive objects are directly proportional. The amount of mass and the strength of gravity are directly proportional. Also, the distance, the further away an object is, and the way in which it redshifts because of that distance is also directly proportional. Thus, giving the idea that light itself is a little packet of very little mass, very, very little mass, but just enough. I don't really like to think of space of like a fabric, so to speak. It's just simply massive. Gravity's just simply a field, and anything with mass is affected by this field, whether it's electrically or conductive or not. It's all affected. So if it affects everything and electricity only affects a couple things, those things that are conductive, I cannot conclude, based off the Thunderbolts project guys, that electricity played the evolutionary role in the structure of the universe. Have a good one.